Hello everyone, good morning. Welcome to the live lecture of Doubtnet. So we were doing our chapter haloalkanes and haloarenes, and we have started the chemical reactions of haloalkane. We have understood the haloalkanes undergo nucleophilic substitution reactions, and we'll continue this topic, and we'll understand today there are two types of nucleophilic substitution reaction, that is SN1 reaction and SN2 reaction. We'll understand that, but before that we have to understand a small topic which is about nucleophile, and we'll understand what are ambident nucleophiles, right? So this would be lecture number 11 up till now. If you have missed anything, you can go and watch that lecture. These lectures are available on Doubtnut app as well as YouTube channel, right? So let's start. If you don't know me, allow me to introduce myself to you. My name is Shagun, and I've done my master's in chemistry from Randa House Delhi University. I've added few qualifications. If you want to give a look to it, you can. Otherwise, we can skip this portion. And so today we are gonna do the chemical reactions of haloalkane. We have already understood haloalkanes are electron deficient substrate. They require electron rich reagents, that is nucleophile, to attack on them. And whenever a nucleophile is used in a chemical reaction, in an organic chemical reaction, the reaction is named as nucleophilic reaction. And since in haloalkane the halogen atom can act as your leaving group, they undergo nucleophilic substitution reaction, right? So today we'll understand what are nucleophilic substitution reaction types, that is SN1 and SN2 reaction, and before that we'll understand the ambident nucleophile. So let's start, but before that we have small announcement. Announcement is that Doubtnut has launched a new course for class 12th students, and this course will be taken by our top teachers who have given proven best results, and there will be doubt clearing sessions too, right? They are your teachers: physics teachers, chemistry teachers, bio teachers, maths teachers, and English teachers. Their videos are available on YouTube channel as well as Doubtnut app. You can go and watch them. What you have to do is you have to download Doubtnut app. There you'll see the live lectures. We'll also give you all the recorded lectures which you have missed up till now. We also give homework in every class. There will be test, weekly test. There are books available for you with the video solutions of the questions. We have NCERT solutions also. Proper timetable will be followed, and in every class teachers notes will be provided in the PDF form. We also tell you how to use app for maximum efficiency. So let's discuss about the best results. We have Harsh Kumar, who was the district topper, Aurangabad, Bihar, and he had scored 91% in class 12th. Similarly, Shreya Ishani scored 91% in class 12th, was the district topper of East Champaran, Bihar, and we have many more students who are the district toppers of their respective uh, states, right? Now, more than 100 students have also scored 85% with Doubtnut, and Doubtnut is #1 institute in doubt solving. We give you homework, notes, test, and all the questions given to you in these processes have video solutions at Doubtnut app. We have classes. You can check the classes at as live classes, as well as you can take the classes in the recorded form, right? To clear your doubts, what you have to do is just click the picture of the question and find the solution on Doubtnut app. We have text solutions available for you as well as video solutions available for you. Or else you can do is comment in the comment section during the class, and whosoever will be the respective teacher will give you the clarification of your question, and you will be notified that teacher has clarified your doubt, and you can check your queries, right? Also, if you have any problem in finding the classes, you can click on the chat section and find out the class on the chat section by writing your query on the chat section, or you can use call now option to find out the classes. If you have any doubt, you can call at 0124-715-8250 or leave a comment in the comment section. Now, can you please tell me whether are you interested in joining this class 12th board course or not? You can write that in the comment section or use the poll to answer this question. Okay. We also have a small announcement that Doubtnut has launched a new English speaking course, and this course will be taken by our top teachers. This course has already started from 8th July. Whatever you have missed till now, you'll get in the recorded form. If you want more information regarding this batch, regarding this course, you can check out the comment section. We have given you the description link. You can check all the information from there, right? Okay. So let's come to our topic, which is the chemical reactions of haloalkane. We have already understood that your substrate haloalkane, an organic chemistry, was in general written as substrate plus reagent in solvent conditions. In solvent, you have to mix them. You have to solubilize reagent and substrate in a solvent. If there is any pressure temperature condition, you write that on the arrow and you get the final product. The general organic chemistry is written in this manner. I have told you that substrate and reagent first of all attract towards each other, then they collide, and certain amount of energy is released. That energy is used for breaking of bond. That energy is used for breaking of bond as well as for formation of bond, and after this breaking and formation of bond, your final product is obtained. The prime step for a chemical reaction to occur is attraction between substrate and the reagent. If there is no attraction between substrate and reagent, no chemical reaction can occur. First of all, attraction happens, and then they collide, and then the energy released is used in bond formation and bond breaking. And generally, the breaking of bond is the bond breaking of an old bond, and a new bonds are formed, and finally the product is released, right? So the prime step is attraction. For attraction, reagent and substrate should be of opposite nature. If your substrate opposite just a second, it should be of opposite nature. The nature of reagent and substrate should be opposite, right? If substrate is electron rich, if substrate was electron rich, your reagent has to be opposite nature, that is, it should be electron deficient. And as I told you, electron deficient reagent is known as electrophile, and whenever an electrophile participates in a chemical reaction, it shows electrophilic reactions. And electron rich substrates were your pi bond containing molecules. For example, your benzene, naphthalene, pyrrole, pyridine, and so on. They were your electron rich substrate that have excess of pi bonds, because pi bonds have loosely held pi electrons, and hence we say the substrate is electron rich. But in the case of your haloalkanes, since halogen is electronegative, it takes the electrons of carbon and halogen bond through itself via inductive effect and develops delta negative charge on X, and delta positive charge is developed on R. Whenever you have R delta positive or R positive, that means they are electron deficient substrate. Electron deficient substrate requires electron rich reagent, because it should be opposite, or it should be of opposite nature. Electron rich reagent is known as nucleophile, and whenever a nucleophile participates in a chemical reaction, that chemical reaction is particularly known as nucleophilic reaction. Now we have nucleophilic addition, we have nucleophilic substitution reaction. What depends whether the reaction is substitution or addition? What is decided by? It is decided by whether we have leaving group in your substrate. In haloalkanes, leaving group, the halogen acts as a leaving group. We have leaving group in a substrate, and hence in haloalkanes, nucleophilic substitution reaction occurs, right? We have discussed this already. In haloalkanes, nucleophilic substitution reaction occurs. Now this is the way the chemical reaction is generally represented as: due to inductive effect, X halogen develops delta negative charge, carbon develops delta positive charge. Nucleophile, which is the reagent, is opposite to delta positive charge. It attracts carbon delta positive, because negative positive attracts towards each other, and the substrate, the new bond between carbon and the nucleophile is formed, and the old bond between your carbon and halogen is broken, and X minus is released. This is the leaving group. So this is the way your nucleophilic substitution reaction is represented in your haloalkanes. These were your nucleophiles and they usually show nucleophilic substitution reaction. The reaction is Rx with nucleophile, a new compound or a new product, R nucleophile is formed and X minus is released. For example, as I have already told you, NaOH, KOH or water is used to prepare your alcohols from your haloalkane. This is your haloalkane, Rx is your haloalkane, and NaOH and water were used to prepare your alcohols. Because NaOH, we have already discussed this, NaOH is a source of OH minus ion. Here the nucleophile is negatively charged nucleophile and it attracts to the substrate. The chemical reaction takes place in this manner. OH minus attacks delta positive carbon and removes X minus. From haloalkane you obtain alcohol and X minus is released. Similarly, this reaction can take place with a neutral nucleophile also, that is water. Since water, oxygen attached to oxygen in water has lone pair, it attracts. Lone pair means it has high electron density. It attacks R delta positive and removes X minus. Since lone pair is donated, oxygen positive charge appears on oxygen, because whenever a neutral molecule donates its lone pair to form a bond, it a positive charge develops on it, right? Whenever a negative charged nucleophile forms a bond, from negative it becomes neutral and from neutral it becomes positive, right? Say if it was a neutral molecule, it will develop a positive charge, and negative molecule develops into a neutral form, right? ROH is formed. Oxygen has donated its lone pair, positive charge develops on it, and you have removed X minus. X minus then takes its positive and forms again alcohol. So in this manner, using NaOH, KOH or water, you form alcohol from haloalkanes. Now to form ether, you use NaOR dash. OR dash NaOR exists in the form of Na positive and R dash O minus. Again in this reaction, if R dash O minus participates as a nucleophile, Rx is your haloalkane, R dash O minus acts as a nucleophile, attacks carbon, removes X minus, a new bond is formed between R and oxygen and the old bond is broken between R and X, and X minus is released. Now this is the new functional group which is known as ether. How do you prepare ethers from haloalkane? Is the reaction with your NaOR, right? Also we have discussed this NaI minus is this I minus is the source of your is the nucleophile that attacks Rx and replace X with I. This was the Finkelstein reaction. We have understood this reaction in while preparation of your iodoalkane or alkyl halide. This was your Finkelstein reaction. Similarly, we can prepare primary, secondary and tertiary amines using these reagents. This is really important. So the chemical reaction looks like, if I have Rx, which is your haloalkane, I wish to prepare primary amine, I will use my neutral nucleophile, which is ammonia. Nitrogen has lone pair, attacks carbon and removes X in the form of X minus. Nitrogen has donated its lone pair, a positive charge develops on it and NH3 is formed, X minus is released. If I open this nitrogen-hydrogen bond, it seems like it has 3 hydrogens. To form the neutral molecule, X minus takes H positive forms negative, negative, positive cancel outs and it forms RNH2 and X minus is released. This is primary amine. This is primary amine. Whenever your nitrogen is bonded to an alkyl carbon, just one carbon, then it is primary amine. If nitrogen is bonded to 2 alkyl chains, then it is secondary. If it is bonded to 3 alkyl chain, then it is tertiary amines, right? Now how to prepare your secondary amine is by using haloalkane with R, by attacking it with RNH2. Again nitrogen has lone pair, it bonds with R R and removes X minus, a new bond between nitrogen is formed. This is the new bond that has been formed with R. Let this be R dash, and this nitrogen has 2 hydrogen and 1 R dash. X minus released takes H positive and forms R N R dash, and we have 1 hydrogen. Since nitrogen is bonded to 2 alkyl chains, 2 carbons, this is known as secondary amine. This is known as secondary amine, right? So this is the secondary amine. If I talk about how to prepare tertiary amine, take your secondary amine and react it with, let this be R dash, and this is lone pair, and this is hydrogen. Now react secondary amine with haloalkane, you get tertiary amine, right? So nitrogen has lone pair, attacks R, removes X minus, it forms R. Nitrogen has given lone pair, positive charge develops on it. We have R dash attached to it, we have R double dash attached to it, and we also have 1 hydrogen attached to it. X minus takes this H positive, and finally you get R nitrogen with a lone pair. It has R dash and it has R double dash attached to it. You get tertiary amine. You get tertiary amine. So this is the way you form all the types of amines in by reacting your respective nucleophiles with haloalkanes. So we have completed this part 2. This is important you prepare. If you react your haloalkane with ammonia, you get primary amine. If you react your haloalkane with primary amine, you get secondary amine. If you react your secondary amine with haloalkane, you get tertiary amine, right? Now we'll talk about your reaction with your reaction with KCN in AgCN on haloalkane, and this is really important. I really mean it. This is important. Although everything is important, but this is really important. These two reactions are really important. As you can see, if you are reacting with KCN, the product form is RCN. This is known as nitrile group or cyanide group. But when you react your haloalkane with AgCN, the product form is RNC, and RNC is known as isonitrile. Here we'll discuss what are ambident nucleophiles. So let's discuss first what are ambident nucleophiles. Ambident nucleophiles are normal nucleophiles. For example, if I talk about Cn minus, you say this is negative nucleophile, that is okay, but this nucleophile particularly is known as ambident nucleophile. What are ambident nucleophiles? Ambident nucleophiles are the nucleophiles which have more than 1 donor atoms in it. Nucleophiles having more than 1 donor atom within it. That is, if you react Rx with normal cyanide ion, the bond formed is between R. Here the attacking atom is carbon. From Cn, the attacking atom is carbon, and you form RCN. The bond formed is between your alkyl carbon and the carbon of the cyanide ion, and X minus is removed. The donor atom here is the carbon. Donor atom in cyanide nucleophile in this case is your carbon atom, right? But if you take haloalkane and react it with AgCN, what happens is your product formation is RNC and X minus is formed. Since nitrogen in this case has bonded to the alkyl carbon, so the donor atom here is nitrogen. In this case, cyanide, the bond with the alkyl part, carbon can also form the bond, as well as nitrogen can also form the bond. Within the nucleophile, we have 2 donor atoms, carbon as well as nitrogen. Such compounds, such nucleophiles are known as ambident nucleophiles. Similarly, if I talk about your AgNO2 and KNO2, right? KNO2. In KNO2, if you react haloalkane with KNO2, the product form is RONO. RONO is the product form. Whereas that is the donor atom here is your oxygen. But if you react the Rx with AgNO2, the donor, the bond formed is between alkyl and the nitrogen. The new bond formed is this. Donor atom is nitrogen. So this is also your ambident nucleophile, because in ONO, the donor atom can be oxygen, the donor atom can be nitrogen. We have two donor atoms within the nucleophile, or we say we have more than one donor atom within the nucleophiles. Such nucleophiles are called ambident nucleophiles, right? Now we'll understand why if we react Rx with KCN we are getting RCN, and why if we react Rx, that is haloalkane, with AgCN we get RNC. We'll understand that in quite detail. The thing is that, see, as you see the reaction, Cn minus while KCN is taken as a nucleophile, is taken as a reagent, Cn minus is the nucleophile and the bond is formed between R and carbon, that is RCN is formed. If we take AgCN, a new product is formed, but the bond is formed between R and nitrogen. If I take KNO2, this is the nucleophile, the bond formed is between R and oxygen. If I take this, the bond AgNO2, the bond is formed between R and NO2. We'll understand this in quite detail. And the thing is, the story behind this is, if I am reacting haloalkane with KCN, you should know that KCN is ionic compound. It is ionic compound. That is, whenever it is dissolved in water, it readily ionizes into K positive ion and Cn minus ion. The negative charge appears on carbon atom. The C side of the cyanide atom is in the solution and it has negative charge, where the nitrogen has only lone pair. If you understand the structure between your uh, potassium cyanide, it is an ionic compound. You should know that if I take potassium or if I take NaCN also, the electronic configuration, you know, it is the first group element. The electronic configuration of hydrogen is 1. It has 2 1. For lithium it is 2 1. For sodium it is 2 8 1, and for potassium it is 2 8 8 1. You know that, right? We have done this in class 10th also. The electronic configuration of potassium is 2 8 8 1, right? To complete its octets according to Lewis theory, it is readily able to lose its electron and convert itself into K positive, and an electron is lost from it. It is an alkali metal that loses one electron, and this step is done because in this case, whenever an electron is lost from K, the electronic configuration becomes 288. Now it has, your last valence shell has octet complete. It is quite stable. The electron released, now it's taken by whom? If I talk about carbon, carbon has 4 electrons, right, in the valence shell, and nitrogen has your 5 electrons. Nitrogen needs to complete its octet. Nitrogen needs to complete its octet. It should bond. It only has 5 electrons in the valence shell. It requires 3 more electrons. So carbon and nitrogen bonds themselves in 3 covalent bond, because in this case nitrogen now has octet complete, because nitrogen has 2 electrons in the form of a lone pair. It has 6 electrons in the form of a covalent bond. The octet of nitrogen is completed, whereas octet of carbon is yet not completed. It is 1 electron deficient. It has 3 bonds. The bonds here are covalent bonds because nitrogen has shared its 3 electron as well as carbon has shared its 3 electron. The covalent bond between carbon and the nitrogen leads to 6 electrons to nitrogen as well as 6 electrons to carbon, right? Now since carbon has 4 valence electrons, 3 of the electrons has formed your covalent bond. Now it has 6 covalent electrons, and one electron in its valence shell. The carbon has yet not completed its octet. It is only 7 electrons. It requires one more electron, and that electron is given by the potassium. Because potassium has converted itself into K positive ion, the electron lost is taken by the carbon atom, and carbon now has 2 electrons, and these 2 electrons are shown in the form of negative charge. Nitrogen 2 has lone pair, and carbon has a lone pair which is shown in the form of a negative charge, and whenever carbon takes one electron, it develops a negative charge, and negative charge is developed on carbon. If your compound is ionic, Cn minus is released, carbon attacks your carbon has negative charge, it attacks your R delta positive and remove X minus and form RCN, right? This is due to the ionic compound. The attacking species is your carbon. But if I talk about AgCN, the bond between Ag, which is your silver metal, and the carbon is a covalent bond. It is a covalent bond. As we know, carbon has 4 electrons, nitrogen has 5 valence electrons. Nitrogen required 3 more electrons to complete its octet. Because it has already 5, it requires 3 more, so it covalently bonded with carbon, and in covalent bonds of the nitrogen, it fulfills its 6 electrons and 2 electrons in the form of lone pair. Octet of this is complete. It is your 5 plus 3, 8 electron species, but carbon octet is yet not complete because 6 electrons in the covalent bond with the nitrogen and 1 makes it 7 only. So it asks silver to covalently bond with it. So the bond between silver and the carbon in AgCN is a covalent bond. And covalent bond is very difficult to ionize. It is not ionizable bond. The carbon is covalently bonded with AgCN. The electron density now on nitrogen is free. It is free, and hence the attacking takes place by nitrogen atom and not by the carbon atom. And X minus is removed once the bond is formed. Rn triple bond C is released, right? So this is the way things happen. This is only because silver and the carbon bonds are covalent bond. It is quite stronger bond. Free electron density is not available on carbon. That attacks in the way the cyanide the cyanide ion has attacked attacked in your KCN, right? So this is the reason why AgCN, if I react your haloalkane with AgCN, nitrogen attacks your R and forms your isonitrile, whereas if KCN is taken, it ionizes. This electron density on carbon is free, and preferable attacks takes place from carbon only, right? So this is the reason why your different types of products are formed, and since the donation has happened from carbon and nitrogen both, they are your ambident nucleophile. Similarly, if I talk about KNO2 and AgNO2, first of all we need to understand what is the structure of your NO2. Nitrogen has 5 electrons, right? Nitrogen requires 3 more electrons. Oxygen has 6 valence electrons. Oxygen requires 2 electrons to complete its octet. First of all, what happens is nitrogen and oxygen bonds are formed. One of the nitrogen and oxygen bonds are formed. Octet of this oxygen is completed because it has 1, 2, 3, 4 electrons in the form of a lone pair, in form of 2 lone pair. 5, 6, 7, 8 electrons of oxygen are completed. If I talk about nitrogen, it has 1, 2, 3, 4, 5, 6, 7 electrons, right? It also has one oxygen atom, which is this, right? Now what happens is a coordination bond is formed between your nitrogen and your oxygen, and the structure in case looks like the coordination bond is formed between nitrogen and oxygen, and oxygen gets negative charge, nitrogen has given its one of the electron, and this is the structure of your NO2 minus. Now if I talk about K positive, the simple thing is like K positive is bonded with your oxygen minus ion, and whenever KNO2 is released in water, it ionizes in the form of K positive and NO2 minus. Remember that the negative charge is on the oxygen, and since negative charge is on the oxygen, whenever our X is reacted with KNO2, O minus attacks and X minus is released. This bond is the ionic bond. It can ionize easily, and hence attack take place from your oxygen, right? So RONO is formed. Whereas if I talk about AgONO, the bond here is your covalent bond. The bond here is your covalent bond. Since covalent bonds are strong bond, now it is not able to donate it. Nitrogen has one electron pair also, but with a positive charge, and this nitrogen now has lone pair because silver and oxygen has covalent bond. It cannot be broken easily. Now if our AgNO2 wants to attack silver haloalkane, it is nitrogen lone pair that attacks R and remove X in the form of X minus, and the bond form is R and N. So the donor atom here is nitrogen. In earlier with KNO2 it was oxygen. KONO was formed, and in this case RNO2 is formed, and this is the final product with when we reacted AgNO2 with Rx. I hope you have understood. It is only because of the ionic and the covalent bond. Ionic says that in cyanide carbon is has free electron, it attacks, whereas in AgCN silver and carbon has covalent bond. It is nitrogen pair which is free, and that attacks, and the bond takes place between R and N. And in the case of KNO2, O minus is free, oxygen attacks, and a new bond is formed between R and O. Whereas in AgNO2, Ag and oxygen bond is covalently bonded. It does not have any free electrons. Nitrogen's lone pair attacks R, and a new bond between nitrogen and R is formed. And in this way, when RONO is formed, this is known as alkyl nitrile, and when RNO2 is formed, it is known as nitroalkane, right? So this is the reaction, and they are your ambident nucleophiles. They are your ambident nucleophiles, right? Now R-COAG, RCO minus acts as a nucleophile, attacks R, and a new R is attached. In case of and this leads to the formation of ester. Now in case of LiAlH4, H minus acts as a donor atom. H minus acts as a donor atom, and when Rx is attached or attracted, or if I take LiAlH4, H minus acts as a nucleophile, attacks this and removes X, and in this case you have formed your hydrocarbon from haloalkane, right? Also, if I take R metal positive, this is your organometallic compound. Organometallic compounds are the compounds when the alkyl carbon is bonded with your metal. This is OMC, organometallic compounds. R minus attacks your R dash X. If I take this, if I take Rx and I react it with RMgX, the metal and carbon bond is formed. Such compounds are organometallic compounds, where organo specifies carbon and metal is your magnesium. This is your organometallic compound. The bond R has negative charge, attacks and removes X minus. A new bond between R and R dash is formed. This is your formation of alkanes from haloalkane using Grignard region or any other organometallic compound. So this was it. We have completed your nucleophilic substitution reaction, and that big table has been completed. You can easily go through that and revise that also. We'll do the previous year questions too about such this, but first let's complete your SN1 and SN2 reaction. Now we don't have much time. We'll take SN1 SN2 reaction in next class, but before that we have quiz for you. So I hope you have understood all the concept and you will do the quiz correctly. If you know that, do that 100%. If you don't know that, uh, at least answer that in the answer that quiz. Rest I'll explain you the answers too, right? So this is the first question. You have to tell me that C2. This is assertive assertion and reason reaction statements, and you have to tell me the relation between A and R. Okay, so let's go to next question. You have to tell me in this reaction what are the organic products formed? Which type of organic products will be formed? Be careful about this question. Okay, it's done. Let's understand. I hope you have done all right. We'll understand with this. In this question, the assertion statement is given that C2H5Br, this is your bromoethane, and alcoholic silver nitrate, that is you are reacting C2H5Br with AgNO3. Sorry, silver nitride. It is nitride, it is not nitrate, so it becomes AgNO2. Reacts to give nitroethane, that is it says C2H5Br when reacted with AgNO2 it forms nitroethane, that is C2H5NO2. We know this, right, as a major product. This is the major product, right? The reason here is NO2 minus is ambident nucleophile. This statement, above statement, is true statement because we know in AgNO2 the oxygen and the silver has covalent bond. It is nitrogen that has a lone pair which is free and it attacks, and the bond is formed between alkyl part and the nitro group and an N group, N atom, so the product form is nitroethane. The statement here, assertion statement, is true. If I talk about the reason statement, NO2 minus is ambident nucleophile. This is also the true statement, but this is not the clear reason for your assertion statement. The reason here is NO2 minus is ambident nucleophile, but the correct reason is the silver and oxygen are covalently bonded. It is nitrogen lone pair that is free, and hence attacks takes place through nitrogen and RNO2 product is formed. RONO is not formed, right, in the case of AgNO2. So both the statements A and R are true. Individually they are true, but R is not the correct explanation for A. So the correct option for this question is option B. I hope you have understood. We know assertion is a right statement. Whatever it has written, it is true statement. NO2 minus is also an ambident nucleophile. It is also a true statement, but this is not the correct explanation for your assertion statement. So A and R are true, but R is not the correct explanation of assertion reaction, right? Assertion statement. Now, if you react this species with cyanide ion, what happens is it is just like you see, this question is basically from your, it is just like the negative. See, what all products are possible. It is just like the Cn minus can attack this carbon and remove Cl minus. What sort of product is formed is CH3CH double bond CH CH2, and instead of Cl you have cyanide. So this is the product. A type of product is also possible, but this reaction can also occur at your carbon with the double bond, because if it is attacked on this carbon, the double bond shifts here and then Cl minus can be removed from here too. If the attacks takes place on this carbon, the product form type is CH3C. The attack has taken here, from double bond it has turned to single bond and then double bond, and the Cl minus is removed. This is also the product which is formed. A and B both are the products possible and hence your both A and B products are possible. The correct option for this question is option C. It is not individually A and B. It is not individually. This is only formed. The reaction can happen in this manner also. As you can see, if Cn minus attacks here, pi bond shifts and removes Cl minus 2. So this is also the possible product. This is really important. You can you can remember this. So the correct option is option C. So we have completed our quiz. We'll start with your nucleophilic substitution reaction type in next class. Today we have discussed your ambident nucleophiles. What are your ambident nucleophiles? And we have completed all the nucleophilic chemical reactions that were used in your haloalkanes, and we have completed a quite big table. Now we'll meet for nucleophilic substitution reaction part 2, in which we'll be discussing your SN1 mechanism and SN2 mechanism in quite detail with examples, and we'll meet at 10:30 on Friday. Right? We'll meet on Friday. Till then, I hope you have liked the lecture. If you have any problem, anything you want to share, you can write that in the comment section. I'll check that out. Till then, thank you so much for watching and have a nice day.